Hey students, in this video we're going to learn how to write quadratic equations in vertex form. So you need to understand that there are three different forms of writing quadratic equations. So far in Algebra 1, you were only exposed to this standard form and a little bit on vertex form. So what's new to you will be intercept form, but we'll talk about that in another video. Before we begin the notes, though, I want to mention that you can do an exploration activity before the practice or even before the notes. I'll just give you a glimpse. It is going to be a Desmos activity. I'm going to show you just the sample, but if you want to keep exploring it, here's the information. So pause the video and log in and try it a little bit if you want, and then just come back to the video when you're ready. So when you go to that website and click on the code, you're going to be asked to sign in. You don't have to sign in. You could continue without signing in. Just make sure that you put your first name and last name. That way I know who did it. And then you just go to the activity. So the activity is going to pretty much just a game sort of. So your goal is to get this ball to go through all those stars. So this is just an example of what you want to do. When you go to the next slide, it's going to give you a parabola that gives you that a value and then that h and k value for you to edit and change as needed. For this parabola to change, in order for you to click launch and all those stars be covered by that ball. So for example, you need to remember how valuable each part of the equation is. So this 0.1 is the a value. If I change it to 0.2 or 0.3 or 0.4, so as I keep changing this number, you need to see what's happening to that graph. So you may have noticed that it kind of just got thinner or narrower. So as this number increases, so now it becomes 1, 1.1, 1.2. So as this number increases, the graph gets thinner. So whenever you want the graph to get thinner, you can just make it a really, really big number. So for example, 5 will make it really thin. If I want to make it wider, I will have to make it smaller. So like if I start with 0.5, I decrease it to 0.3, 0.2, 0.1. If I want it smaller, I can go 0.001 or see how big that got. So pretty much just you can play with this a value and make it whatever width of parabola you want. These others, these are the h and k, so you can change these to another number and notice that it moves to the right as I increase that value. So the bigger this number is, x minus h, whatever this h value is, the more it moves to the right. If I wanted to move to the left, I'm going to have to switch this symbol from minus to plus. So now I can change that number again, and it's shifting to the left. So you may remember that the h value is your x value on the vertex. So this vertex right now has a -5, 8 as a vertex, but on the graphic, on the equation, it looks as +5, 8. So this is technically your x value, but opposite sign of what you see right here. So let's go back to what it was. You notice that this has to go downward, so I need to flip this parabola, and in order to flip it, I need to put a negative here in the front, so that flips it. If I click launch, it just goes down and gets that 1 star, so I need to shift this up. So I just want you to kind of play with the parabolas until you figure out a way for all the stars to be collected by the ball. So if I want to shift it up, I'm going to add more on that amount. So notice that 11 is too much. I'm going to put a 10, maybe the 10. So the 10 will only grab those 3 stars, but not that one. So now I got to make it narrow. So that means I got to change this number back to a bigger value. So I'm just going to put 1. That is very, very narrow, but that means I could shift it to the right now. So you just play with it. You just play with it and kind of see what each value does. So if I want to shift it to the right, I'm going to put +3 maybe. I'm probably going to have to put -3. Yep, and then I could try lowering it. So I'm going to put -5 maybe. Actually +5. I don't want to go to the negatives. I want to stay in the positives. So +6, +8, plus 8 is too much. So 7. Let's try 7. Let's try 7, maybe. Nope, it's just staying there. So then I need to make it thinner. So I'm going to try to make it thinner. Or I can actually horizontally compress it too by putting a number in here. Pretty much just play with the numbers. If I want to put 0.12, maybe that one. And it's going, so I'm going to try shifting it up a little bit. 0.5. And there you go. So you grab all the stars. Now this was what I came up with to get all those stars, but the person next to you could probably have different numbers. It doesn't matter what numbers you guys get. What matters is that you understand what these values do. And again, these H and K right here is the vertex, and this A value is the width of that parabola. So with that in mind, you need to have in mind how valuable that A value is whenever we have equations. We're going to be focusing on the vertex form only. And these are the steps of how to write equations that look in that form. So definitely we're going to need to have an H and K value found or given, and then an A value. So for example, you're going to need to identify the vertex, and that will be your H and K, which will be those values right there. And you're going to have to use a second point in the graph, and those will be your X and Y point right there. You're going to plug in each letter, H, K, X, and Y, from the step 1, the ones you identified. And then you're going to plug them in into this template, this format. So you're going to have all the letters Y, X, H, and K with numbers except A. So then you're going to be solving for A. Again, A is something you cannot find just by staring at the graph. You're going to have to calculate it mathematically. And that's the whole point of these notes right here, for you to know how to calculate for that A. After you find that A, you're going to rewrite the equation with the A, the H, and the K substituted, and then just finalize it as your vertex form. And then you'll be done. So here's an example done for you. The vertex is given, and that's your H and K. This point is given, and that's your X and Y. The vertex form is right here, and you're going to substitute the H, the K, the X, and Y. So those values right here are all replaced with the values that are up here. When you do that, it looks like this. Actually, over here, the 12 and the X as well are replaced right here. So then notice that everything is just numbers except the A. So you use the solving skills to find A, what A equals. So you multiply here, negative times negative is positive, and then you combine like terms, -2 plus 6, that's +4. Then you do PEMDAS, which is square of 4 to the second power, so that's 16. Then you have 12 equals 16a minus 4, so you add 4 to cancel that -4, and you end up with 16 equals 16a, so then you divide both sides by 16, and that's how you get a equals 1. So technically, this is what you need to practice, that process. How to write a vertex form equation from just a vertex and a point given to you. All right, so let's try some examples. I'm going to try the examples on the left. You can practice the ones on the right. So there's more than that. If this video is too long, just fast forward to the sections that you want to see. So write the equation of a parabola that has a vertex of 3, -6, opens down, and it's congruent to this. So that information is telling you that you're going to have an HK value of 3, -6 is going to open down. So that means your A is going to be negative. It's going to also be congruent to this equation. So this equation has an A value of 1/2. So that's telling you, sorry for the bell, guys. You know, I'm recording during school. This A value is telling you that the width of that graph needs to be the same width of this graph. So they're already telling you that the A has to be 1/2. That's what that's saying. Congruent to this, A has to have 1/2. Put these together, that means A is -1/2. All right, so on this one, because they're giving you the A value and because they're giving you the H and K value, you just write your template down, which is y equals A x minus h squared plus k. And you're going to replace the A value, the H value, and the K value. So y equals -1/2 x minus your H, which is 3, square plus K. So because the K is negative, we're going to put -6. So this is the equation given this explanation. Try the practice problem and check the video afterwards. So pause the video so you can try that problem real quick. Okay, so let's go over the practice problem just to make sure you did it correctly. So the congruency part is right here. This is the A value. So we're going to have an A value that is 3. This is the vertex right here. So your H and your K, HK, that's 4 and that's 2. And then your equation template is A x minus h squared plus k. And you're just going to replace those 3 values. So y equals A is 3, x minus h is 4, squared, k is 2, plus 2. So this should be the answer that you got when you did your problem. All right, let's continue to the next one. So here, this sample says that you have a vertex of 0, 5. It opens up and is congruent to this problem. So that's very similar to the one we just did. We're going to identify the H, the K, and the A value. So we have the H value and K value right here of 0, 5 because it's H comma K, 0, 5. And then the A value, this is A x minus h squared plus k. So then A value is 4. Okay, so we can write our equation following this template of y equals A x minus h squared plus k. And you don't have to rewrite the template over and over if you already know the template. So y equals, and then the A value is 4. X minus h value is 0. Square plus k value is 5. And then because you have a 0 right here, this is x minus 0, which means you are not subtracting anything. So you can just leave it as 4x squared plus 5. But because we want it in vertex form, then just be open-minded that this is what it looks like in vertex form with the 0 there. Okay, pause the video so you can try this other example right here. Okay, let's go over this example. Hopefully you tried it on your own first. Again, similar to what we had, identify your H and K, -7, 0. Your A value, if it says it's congruent to this, you look for your A value. Your A value is right there, 2/3. So then you're going to write y equals a, x minus h squared plus k, and then you replace a, h, and k. Y equals 2/3 x minus, and that's -7, so you're going to have minus -7 squared plus 0. And then you're going to clean it up. So by cleaning it up, I mean simplify. If you have double negative right here, this becomes an x plus 7. If you have plus 0, that means you're adding nothing, so you don't have to put anything on the end. And again, disregard the bell. I'm recording during school. And then here is the equation in vertex form. If for some reason they do have a 0, then just know it looks like this with a 0 at the end. All right, let's look at the back. We have write the equation of the given graph in vertex form. So how do you graph it? How do you write it from a graph? You just gotta look for your vertex. That vertex is your HK. So here it's gonna be -1, +3. So that means that in your equation of a x minus h squared plus k, we already have the h and k in here. Minus -1 plus 3. And then when it's double negative, this simplifies to being x plus 1 squared plus 3. So if you notice, the only thing you have here is the a. The a is missing. And to calculate that a, it goes back to what I was saying in this example right here, where you could calculate that a value by finding also a point that the graph goes through. So let's look for a point that this graph goes through. It looks like it goes through here, here, and I think that's all as far as precisely. So this is 0, 1. This is -2, 1. So you just pick whichever point you want to work with, and you do the math behind it. So because the zeros usually work on your favor, we're going to work with this one right here. So we're going to try substituting the y value and x value with this x and y value. So the y value, according to that point, is 1. And then x value is 0. Okay, so notice that now we have 1 equals a, parentheses, 0 plus 1, squared plus 3. And then you just solve for that a value individually. So 0 plus 1 is 1. 1 squared is 1. And you end up with a times 1. A times 1 plus 3. So this is a multiplication. We can't separate that until we get rid of that. So minus 3 on both sides. This results in minus -2 equals a times 1, which is 1a. And if this was a number other than 1, you will divide by that number. So I'll just do the process just so you can see it. If we divide -2 by 1, you end up with -2 equals a. So this is showing what a value is. So to put together your equation, you're going to go back to your template, and they're going to say that a is -2, parentheses, x. And then if you recall, you substituted minus -1, which resulted in plus 1. And then squared plus 3. So this is the equation for this graph. And you can always use your graphing calculator to verify any of these to make sure that they are matching what you are discovering or creating. Okay, so pause the video and try this example right here. And then whenever you're ready, just continue. All right, so let's check if you did it correctly. We have the vertex at 2, -4. So that's your h and k. And then you look for another point. It looks like we have a point right here and a point right here. This is 3, -1, and this is 1, -1. So again, you just pick whichever point you want to work with and the vertex. So I'll work with this one, and I'm going to write the template. Y equals ax minus h squared plus k. And you're going to write y. Well, actually, let's just substitute all the values already. So this is your x and your y. So we're going to have, for the y value, a -1. We don't know the a value. And then the x that we're using is a 3, minus the h that we're using is that 2, and the k that we're using is that -4, so -4. All of these we need to simplify to get the a by itself, so 3 minus 2, that gives you 1. 1 squared is 1. So keep in mind that this is a number that's multiplied with a. You still have that -4 at the end, and you still have -1 equals at the front. So before we touch this, we get rid of that -4, so +4 on both sides. -1 plus 4 is +3. And then 1 times a, or a times 1, is just 1a, which is what you want. You want just a by itself, or you can always just divide by 1 if you want, which ends up with 3 equals a. So the equation for this will be y equals a value of 3, parentheses, x minus the h value that we had, which was 2, and then the k value that we had, which was -4. So this will be the vertex form given this graph. All right, let's try another one. And this is without the graph, but just the information. So same process. We're going to write this vertex as hk and the point as xy. So the template to start with is y equals ax minus h squared plus k. And then you replace all these 4 variables except for a. Y value is 8. X value is 1, H value is 2, K value is +5. And then as the more you do these, the more you notice there's this pattern where you can move that 5 already to the other side. The number that's on this side can be canceled. And you end up with 3 equals. And as you're moving, you can keep simplifying. 1 minus 2, that's -1. -1 squared, that's +1. This is already gone. So then now you're here where a times 1 is 3. And again, we divide by 1, it's just a equals 3. So the final answer here will be y equals 3, parentheses, x minus your h value, which is 2, squared plus 5, your k value. And you're done. All right, pause the video so you can try this next problem. Whenever you're ready, press play. All right, let's try this and check if you did it right. So the point is x and y. Vertex is h and k. Template for this is y equals ax minus h squared plus k. Substitute all of these 4 values in and leave the a value by itself. Y is +2. A, x is -2. Minus h value is -4 squared plus k, which is 6, plus 6. So then now we have simplification. Again, this +6, we can subtract it now. Gone. This part in the inside can be simplified. You can type it in the calculator, just follow pandas. So minus negative, this becomes a plus, so that's -2 plus 4. -2 plus 4, that's +2. And all of this is still being squared. And then the a kind of just keeps following because it's attached to it. 2 squared is 4. So you have a times 4 equals 2 minus 6 is negative 4. All right, so here, because we do have a number next to the a, we're going to divide by 4. And we end up with a equals negative 1. So whenever you get your a value, you're done. You just write your final equation, y equals negative 1, parentheses, x minus your h value, which is negative 4. And when we did it here earlier, minus negative is a positive, so we can rewrite this as x plus 4. And then the k value is plus 6. And that's your equation. All right, last problem. Write an equation given the following. So you have the absolute value, the axis of symmetry. You have the maximum of 5. And if you recall from the previous video, the axis of symmetry and the maximum telling you that it's the highest point going like this, they meet each other. And the maximum is negative 5. The axis of symmetry is crossing at negative 3. So put those together and your vertex is created. The x value is the axis of symmetry. And the y value is your maximum or minimum. So this is your vertex, which ends up giving you that h value and k value. And then they give you the y-intercept. So the y-intercept is tricky because it looks like you need to plot it in a graph. But again, a y-intercept is a point. So they're actually giving you a point. 0, negative 9.5. And that's your x, that's your y. So if you're going to create an equation from this information, those are the 4 values you're going to substitute. And for y, we're going to have negative 9.5 equals a times x, which is 0, minus your h, which is negative 3. That looks weird, but it's a 3. And then plus k, which is negative 5. All right, so here, oh, I forgot that this is a negative 3. So it's actually minus negative 3. All right, so if we clean it up, we're going to end up moving this negative 5 to the other side. So that's positive 5. Positive 5 cancels. Here we have double negative, so that becomes 0 plus 3 squared. And then that becomes 3 squared. So then that becomes 9. So we're going to end up multiplying a times 9. And then on this side, we have negative 9.5 plus 5. So we end up with negative 4.5. Then we're going to get rid of the 9 and we're going to divide by 9. So when you divide this, you probably will go to your calculator for this because you have a decimal. So just to show you that, we're going to have negative, let me lower the brightness here, negative 4.5 divided by 9. And that is negative 0.5. So a equals negative 0.5. Some of you may have gotten a fraction based on the settings on your calculator. So if you did, it's just negative 1/2, which is the same thing. So to finalize this, the equation for this will be the a value that you found and the vertex that you found. So we're going to have y equals negative 1/2 parentheses x plus 3 because it's a minus negative. And if you recall, we ended up with putting a plus squared and then minus 5 because that's your k value. So this is the equation. All right, so pause the video and try this next one. And it's the last problem, so let's do this real quick. Okay, whenever you're ready, hopefully you got a chance to do this on your own first. Axis of symmetry, again, it's the line that crosses the parabola in half or cuts it in half. Minimum means that it's going to have a point and it's going to turn up because that's the minimum, the lowest, and it's at -4. So if this is at -4, the lowest, and then the axis of symmetry is cutting at +3, put those two together and it creates the vertex right here of 3, -4. This is your x value, this is your y value. And then it tells you that it goes through this point. So that's your x and that's your y. So if you write the template for this, you will have -2 equals a value +2 minus 3 squared minus 4. So that's your y, that's your x, that's your h, and that's your k. Okay, so then we move this 4 to the other side, so add 4. And then 2 minus 3 is -1. -1 squared, it becomes +1. And again, this is multiply times a. -2 plus 4, that's +2. So then if you divide this by 1, it's just a equals 2. So to finalize this, use the h and k values and the a value, and y equals 2x minus 3 squared minus 4. All right, hope this video helps you understand how to write equations given a vertex and a point.